Alright, problem number 3 says, the back-to-school sale at Cheap Mart offered Spiral notebooks for a whole number of cents. Brennan brought some Spiral notebooks, and the total came to $3.77 before tax. Molly also bought some Spiral notebooks, and her total came to $2.03 before tax. How many more notebooks than Molly did Brennan buy? Alright. So, my hint to you would be to look at these two numbers, okay? And I probably would convert them to cents. So let's say we have 377 cents. That's the same as $3.77. And 203 cents. And we know that in order to get 377, we know that 377 has to be the product of the number of notebooks that Brennan bought times the price per notebook. And we know that the notebooks cost a whole number of cents, and we know that Brennan bought a whole number of notebooks because they really wouldn't sell you half a notebook or a third of a notebook. Okay, you have to buy a whole notebook or nothing at all, right? So the number of notebooks is going to be a whole number. The number of cents per notebook is a whole number. So this number has to be, 377 has to be a product of two whole numbers. And the same holds true for 203 cents. We got that by taking the number of notebooks Molly bought times the cents per notebook, and that gave us 203. But both of those numbers, the number of notebooks and the number of cents per notebook, are whole numbers. So 203 has to also be a product of whole numbers. So my hint to you would be to look at the factors of these numbers. And they should have a common factor, which is the number of cents per notebook. Okay? Because in both of these we took the number of notebooks they bought times the cents per notebook, and the cents per notebook is the same for both Molly and Brennan. Okay? So they'll have a common factor of the number of notebooks. Okay? Another thing you could do is you could look at the difference of 377 and 203, because if we take the difference in the amount they paid, that will be the number of cents per notebooks times the difference in the number of notebooks they brought. Okay, so if we took 377 and we subtract 203, we'll get 174. So that again will have a common factor, which is the price per notebook. Okay, because 174 will be the price per notebook times the difference in the number of notebooks they bought, because it's the difference in the amount they paid. Okay, so you could also look at the factors of that, and it should have a common factor with these. Okay, so that's my hint. And here's the solution. What you would need to do is factor these numbers and find the common factor. Alright? I'm going to start, I guess, let's just start with 74, or 174, because it's small and it's even, so it's easy to divide it by 2, right? So that's 2 times 87. Okay? Now, 87, if you add the two digits, 8 plus 7, you get 15, so you know that this has to be divisible by 3. So that ends up being 3 times 29. Okay? So, and 29 is a prime number. Okay? If you don't have all your prime numbers memorized, you could test it just by taking, going through the prime numbers. Start with 2, no. 3, no. 4, no. 5. Let's see. Well, 4 is not a prime number. Sorry. 5, no. 6 you don't really have to test, because 6 times 6 would be 36, and so that's bigger than 29. So it's a prime number. So, um, so we know that the factors, there's a lot of different factors here of 174. You've got 2, 3, and 29, but you've also got 2 times 3, so 6 is a factor of 174, and 2 times 29, which is, 58, is also a factor of 74. So let's take a look at these other ones and see if we can figure out the factors of them. So let's take a look at 203. I like it because it's small. We'll do the smallest ones first. They're a little easier sometimes to factor. So again, we can just go through the prime numbers. Is it divisible by 2? No. 3? Well, the digits add up to 5. No. So that's not divisible by 3. 5? No, because it doesn't end in 0 or 5. 7? Well, let's just try 7. If we divide 7 into 203, let's see, we'll get 1463. Look at that. So 203 is 7 times 29. Okay? And lo and behold, look at this. 29 is prime, 29 is a common factor between the two. 7 is also prime, so it's not a factor. 2 and 3 are not factors of 7. So we found a common factor. So we know that has to be the price per notebook. And so then we could look over here. This was the difference in the amount they paid. So the difference in the amount they paid should be the price per notebook times the difference in the number of notebooks they bought. So you can see that 6 times 29 is 174. So the answer has to be 6. So let me just write that out. Brennan bought 6 more than Molly. Okay, and 6 is our answer. Okay. So in this case we used the difference between 203 and 377. You wouldn't have to do that. You could also factor this one. And again, this is kind of a tricky one to factor, but just a matter of going through all the primes. Is it divisible by 2? No, because it's not even. Is it divisible by 3? No, because I just don't add up. Is it divisible by 5? No, because it's not in 5. How about 7? 7, we could divide that. We could, just like we did over here, we could divide it, but I'll tell you it's not divisible by 7. So with the next prime number 7, B. And the one is that you take alternates, add them, and then they're alternating. In this case, only 1. So 3 plus 7 is 10, minus 7 is 3. And that's not a multiple of 11, so this whole is not a multiple of 11, okay? I'm going to post some all these so I'm going to post on the divisibility rules, so you'll see why that works for 11. But for now, it's not divisible by 11. You could test it too by trying to do it, but it doesn't work. This one is 30, and out that 30 times 29 is 377. So again, we found the common factor between these two numbers, and so that has to be the price per notebook. So Brennan bought 13, Molly bought 7, and the Dix